All right, for number one here, the trick to evaluating this limit is to multiply top and bottom by the conjugate. Okay, so notice basically what you have here, you have a square root minus something. If you multiply top and bottom by a square root plus that thing, okay, and you do want to put that in parentheses. Okay, and really when you multiply, that's got to be in parentheses too. Okay, so let's see what happens. So we got a limit as h goes to 0. The bottom, I'm really not doing anything with the bottom. I'm just multiplying them together. I'm not even going to distribute there. On the top, I'm going to use the multiplication fact that when you have something like a minus b times a plus b and you FOIL it out, you end up getting a squared minus b squared. Okay, so notice that this product here is exactly that form. So what's going to happen is you're going to end up getting the square root squared, and when you square a square root, you just get what's underneath. Whoops, 4 plus h. Right, so if that's your a, then that's your a squared, and then b is 2, so b squared is 4. Okay, on top you got 4 minus 4, so those cancel. So we got a limit as h approaches 0, h over h times this thing. And on top here, notice h, I mean that's the same thing as h times 1, and I write it like that because notice you got a common factor of h on top and bottom, so those cancel. Okay, so really it's just limit as h goes to 0 of 1 over this thing in the parentheses. And notice that at this point I can actually, if I want to take a limit as h goes to 0, I can just plug in h equals 0 and there's no problem here. So if you just plug in h equals 0, you'd have 1 over the square root of 4 plus 2. Of course, square root of 4 is 2. 2 plus 2 is 4. So the whole thing is equal to 1 over 4. Okay, so that is number 1. For number 2, the algebra that you want to do, basically anytime you have you got a big fraction here and then you have little fractions within the big fraction, what you want to do is you want to multiply top and bottom by the LCD of the little fractions. Okay, so like if you were to get a common denominator between those two, what would it be? It'd be 5x. So I multiply top and bottom of the big fraction times 5x. And again, when you do that, there's really parentheses all over the place. So this is going to be a limit as x approaches 5. On the bottom, I'm just going to leave it as x minus 5 times 5x. Okay. On the top, I'm going to distribute the 5x to both of these terms here. 5x times 1 over x, that's 5. 5x times 1/5, that'd be x. So notice, right, I got 5 minus x and x minus 5. Those are almost the same. And in fact, if I factor a minus sign out of the top, if you factor a minus sign out of the top, all of a sudden now you do have the exact same factor on top and bottom. So those do cancel. So now this is a limit, it's still a limit as x approaches 5, but now it's minus 1 over 5x. And now, to take this limit, you can just plug in x equals 5 and there's no problem. If you plug in x equals 5, this would be minus 1 times, or over 5 times 5, which would be minus 1 over 25. Okay. The reason that you have to do tricky algebra with both of those is because if you look at both of these limits right off the bat, right, with number 1, the limit as h goes to 0, notice you can't just plug in 0 right off the bat because you'd be dividing by 0. Okay, Okay, that's why you have to do all the algebra first. Similarly here, notice right off the bat you can't just plug in x equals 5, because on the bottom here you'd have 5 minus 5, which is 0. Can't divide by 0. So right again, you can't just plug in a number right off the bat. You have to do a little bit of algebra first and hope to get some kind of cancellation on top and bottom. Then you can just plug in a value for x to do these limits.